Buildings are responsible for 40% of the total energy consumption and 36% of the total CO2 emissions in Europe. Spending less energy in heating and cooling building spaces is an effective action against climate change and will also contribute to decreasing Europe's energy import dependence. In 2009, the European Commission launched an ambitious program to tackle these challenges. It is financed jointly by industry and the European Commission under the 7th Framework Programme for Research. The objective of the Energy Efficiency Public-Private Partnership is to speed up research on key technologies and develop a competitive industry in the construction sector with the focus on energy-efficient processes, products and services. The NANO E2B cluster comprises of 6 projects funded under the working topic of new nanotechnology-based high-performance insulation systems for energy efficiency. With a total budget of 24.2 million euros, the NANO E2B cluster includes 11 large enterprises and 16 small-medium enterprises, 17 research and technological organizations, and 5 universities. The NANO E2B cluster uses nanotechnology as a key technology in order to develop high-performance insulation materials to significantly enhance the energy efficiency of buildings. Cool Coverings is a research project involving 14 industrial and research partners from 8 European countries. The main objective is to develop multifunctional coatings for the building envelope that stay cool under sun radiation, reducing cooling energy consumption, improving indoor comfort, and mitigating urban heat island phenomenon. Compared to white or light materials, colored surfaces absorb a large amount of solar energy with a significant increase of indoor temperature.
The main challenge of Cool Coverings project is to develop covering materials that keep cool under sun radiation. The main idea is to implement nano-based coatings that are highly reflecting, especially in the near-infrared phase, where sun emits more than 50% of its radiation. And it has been applied to 3 materials, ceramic tiles, acrylic paints, and bituminous membranes.
NANO PCM was a research project composed of 8 industrial and research partners from 5 European countries. The main objective achieved was to develop and produce an innovative construction material to improve insulation in buildings. The NANO PCM project was focused on phase change materials. These are materials that can store 14 times more heat per unit volume than standard construction materials. This is why they are great materials for creating high-performance insulation components. NANO PCM uses nanotechnology to incorporate these phase change materials microcapsules to traditional building construction matrices.
The main results of NANO PCM project was to develop and produce at semi-industrial scale energy storage insulation foams able to reduce energy consumption in buildings. The manufacturing process developed involves low carbon footprint processes and also involved almost 100% recovery of the materials involved in the synthesis. Those facts will be an added value for building construction materials in buildings.
Nano Insulate is a research project composed of scientific, technological and manufacturing partners from 7 European countries. They focus their research on improved vacuum insulation panels using a nanostructured core. These are nanostructured materials with the lowest thermal conductivities known to man. The VIPs developed by Nano Insulate offer solutions that are at least 4 times more energy efficient than conventional thermal insulation. They are thin and lightweight, provide product lifetimes of over 50 years, and can be opaque or transparent. The target is to improve robustness and reduce cost to make VIPs suitable for construction applications.
Vacuum insulation panels, or VIPs for short, provide the thinnest solutions for temperature control of buildings. By lengthening the lifetime, lowering the cost, and improving the robustness of VIPs, we're making them suitable for construction applications where space is critical. This has the potential to save millions of tons of carbon dioxide and help Europe meet its energy security needs for the future.
AeroCoins is a collaborative research project involving 5 RTD organizations, 2 large industries, 1 high-tech SME, and 1 university from 6 European countries. The main objective is to create a new super-insulating aerogel-like material with improved thermomechanical properties. The new material will be synthesized in the lab and developed at pilot scale. Then the fabrication concept for cost-effective mass production will be laid out. At the moment, silica aerogels are mechanically weak and require high production costs. These are 2 major obstacles that have prevented a widespread use of silica aerogels insulation components in the building industry. AeroCoins offers specific solutions to these issues.
At AeroCoins, we are developing new methods for strengthening silica aerogels using cross-linking with cellulosic polymers or by incorporation of cellulose-based nanofibers. In addition, we are promoting ambient drying and a continuous fabrication process.
The HiPin project comprises of 9 companies from 4 European countries with very distinctive expertise. Their main objective is to engineer a high silica content and multifunctional precursor to produce aerogel that can be more robust, self-cleaning, and cost-effective. This aerogel can be incorporated into paints, cement, and insulating membranes to have high thermal insulation performance in a form that is easy to apply. HiPin develops the required nanotechnology to be easily applied to interior and exterior of new or old buildings. This project enhances the aerogel properties that could also be exploited by other building materials such as bricks, blocks, or roof tiles.
Aerogels have got high insulation properties. In HiPin project, we are making a high silica content precursor to make the aerogels. The process route that we follow will reduce the cost of the aerogel significantly and make it mechanically robust. We are also evaluating how to incorporate aerogel into paint, plaster and panel systems. The project team is quite excited to see the change this project can bring into common building materials.
NanoFoam is a research project composed of 4 European partners. The project objective is to develop a high insulation performance thermoplastic foam with carbon dioxide as blowing agent. Conventional foams have pore sizes around 300 microns. The NanoFoam will have pore sizes between 100 and 200 nanometers. With this nanopore size, NanoFoam will offer lower thermal conductivity than commercial insulation products at a competitive price. NanoFoam will greatly enhance the energy efficiency standards in new and existing buildings and will meet European Building Code requirements for mechanical, fire, and moisture resistance.
Buildings are major consumers of energy, and they constitute an area of major economies as well. So it was about 4 years ago that the Commission put together a recovery package in response to the economic crisis. And in that package about 500 million euro are foreseen for energy efficiency in buildings. The 6 projects that form this cluster are part of that package and address the nanotechnology-based insulation in buildings.